Question 19. A, B, C, D, E are points on a circle. B, F, D and A, F, C are straight lines. We're also told that DC is equal to DF. We need to work out the size of angle X over here. So I've scaled up the picture over here so we can annotate this and see what's going on a little bit more clearly. Right, so we've identified that we're trying to work out this angle here, which is X, and we also know this angle here is 2X. So the best thing to do when you're solving a problem like this is to just start working out some of the angles that you might already know. So I know this angle here, BAC, is 24 degrees. And I've got another angle coming from the same chord that is BDC. So BAC and BDC are going to be equal to one another because they're angles from the same chord or angle from the same segment. So I can label that in there as 24 degrees. Okay, so now I know that's 24 degrees. I know that this triangle FDC, well, that's an isosceles triangle because these two lengths are the same as each other. And we're told that in the question over here as well. So if those two sides are the same, these two angles are going to be the base angles, and they are also going to be the same. So I can work those out by doing 180 take away 24. And that gives me 156. So the total of these angles is going to be 156, but because they're the same as each other, I can do 156 divided by 2, and that's going to give me 78 degrees. So each of these are going to be 78 degrees. Okay, now I know that AFC is a straight line, so X, 2X and 78 altogether must make 180 degrees. So I'm going to write this down over here. So I know that X plus 2X plus 78 must be equal to 180 degrees. Okay, so that tells me that 3X plus 78 is equal to 180 degrees, and that tells me that 3x is going to be equal to, and I'm going to subtract 78 from both sides here, so that's going to be 102 degrees, and that tells me that x is going to be equal to 102 divided by 3, which is 34 degrees. So angle x is going to be 34 degrees. Question 20. This sign shows when a lift is safe to use. The total mass of people must be 450 kilograms or less. Ben and some other people are in the lift. Their total mass is 525 kilograms to the nearest 5 kilograms. Ben gets out. He has a mass of 78 kilograms to the nearest kilogram. Is the lift now safe to use? And we need to show our working. Okay, so first of all, let's look at the total mass. Well, the total mass is going to have an upper bound and a lower bound. Because this has been measured to the nearest 5 kilograms, that means that it's going to be either 2.5 kilograms below this value or 2.5 kilograms above. So the total mass, well, the total mass is either going to be greater than or equal to 522.5, or it's going to be less than 527.5. Okay, and now let's look at Ben's mass. So, well, for Ben's mass, that's taken to the nearest kilogram, so it's either going to be half a kilogram below is going to be the lower bound, or half a kilogram above is going to be the upper bound. So we're going to have the mass of Ben, and that's going to be greater than or equal to 77.5 kilograms, or it's going to be less than 78.5. Okay. As Ben has got out of the lift, the calculation we need to do is the total mass of the people in the lift take away the mass of Ben. Now, because we want to be sure that the lift is definitely safe to use, we need to take the upper bound. So we're going to assume that we've got the heaviest possible of the total mass in the lift, and we're going to take away the lower bound of Ben, of the mass of Ben, I should say. So we're going to do the calculation, the upper bound, which is 527.5, and we're going to take away the lower bound over here, which is 77.5. And that's going to give us the upper bound of what weight is remaining in the lift. Okay, so 527.5 take away 77.5. And that gives us 450 kilograms. And because we're told that the total mass of people must be 450 kilograms or less, and it is 450 kilograms, then we can say, yes, lift is safe to use. Okay, this was the worst case scenario, that we had the highest mass to start with, and we took away the lowest mass possible, and we got 450 kilograms, so we know that for sure the lift is going to be safe to use. So the answer is going to be yes. Question 21. Here is a sketch of y is equal to f of x, where f of x is a quadratic function. The graph intersects the x-axis, where x is equal to negative 2.5 and x is equal to 1. We need to circle the solution of when f of x is greater than 0. So we're looking for when this function is bigger than 0. So it's going to be bigger than 0 when it is above our x-axis. That's when it's going to be greater than 0. Anything below our x-axis is going to give us a negative value for our function. Okay, so we can see that it's going to be greater than 0. Well, it starts being greater than 0 at negative 2.5, and it stops being greater than 0 at 1, because that's where the graph now goes under the curve. So it starts over here, and it stops over here. So we've got all of these values in between. Okay, so because it's not allowed to be equal to 0, so this is a strict inequality. I've drawn an open circle over here and an open circle over here. So this is the region of values that we want, and that's when x is greater than negative 2.5 but less than 1. So that's going to be this inequality here, where x is greater than negative 2.5 but less than 1. And because this is just one region, this is expressed as a single inequality. Question 22. Work out an expression for the nth term of the quadratic sequence 2, 17, 40, 71. And we need to give our answer in the form an squared plus bn plus c, where a, b and c are constants. Okay, so there's a few ways of tackling this. We'll have a look at using our second difference. So if we work out our first differences, well, the difference between 2 and 17 is 15. The difference between 17 and 40 is 23. And the difference between 40 and 71 is 31. those are our first differences. Our second differences, the difference between 15 and 23 is 8, and the difference between 23 and 31 is also 8. So we've got a constant second difference here. So we can use that to work out what our an squared term is going to be. And to work that out, we halve this 8 and get 4. So I know that I'm definitely going to have a term that's going to be 4n squared. Okay, so I'm going to write down what the first few terms of 4n squared are going to be. So 4 times 1 squared is going to be 4. 4 times 2 squared, well, that's going to be 4 times 4, which is 16. 4 times 3 squared, that's going to be 4 times 9, which is 36. And then we've got 4 times 4 squared, which is 4 times 16, which is 64. Okay. I'm now going to I'm going to subtract, because I know that this is in the form an squared plus bn plus c. We now know that that term is going to be 4n squared. So I'm going to subtract 4n squared from this here, and that's just going to leave me with bn plus c. So if I subtract this from this sequence here, I should be just left with bn plus c. So I'm going to do 2 subtract 4, which is -2, 17 subtract 16, which is 1, 40 subtract 36, which is 4, and 71 subtract 64, which is 7. So that should just leave me with bn plus c. Now, this should now be a linear sequence, and I should be able to write down what this linear sequence is. It has a difference of 3 each time, so we know that it's going up in 3s, so I know it's going to be, I'll write it over here, we know that it's going to be 3n, and this is actually 5 less than my 3 times table, because that's 3 times 1 take away 5, that's 3 times 2 take away 5, that's 3 times 3 take away 5, and that's 3 times 4 take away 5. So this is going to be 3n take away 5. So I now know that the value of b is 3 and the value of c is -5. So my answer is going to be 4n squared plus 3n take away 5. Now, just as a final check, I'm just going to check to see what my third term should be if I put the number 3 into this expression over here. So that would be 4 times 3 squared plus 3 times 3 take away 5. So that would be 4 times 9, which is 36, plus 3 times 3, which is 9, take away 5. 36 plus 9 is 45, take away 5 does in fact give me 40, and I can see that it works for that term there. So that tells me that this is likely to be true, so I'm happy that that's going to be right. Question 23. Here is a sketch of y is equal to x squared plus bx plus c. The curve intersects the x-axis at 5, 0 and at point P over here. And it also intersects the y-axis at 0, -10 over here. We need to work out the x-coordinate of the turning point of the graph. So our turning point is down here, and we need to work out what the x-coordinate of this point here is. Now, the thing to notice is that the turning point here on a quadratic sketch, or on this parabola, is actually going to be a line of symmetry. And because it's a line of symmetry, it's going to be exactly halfway between this 5 here and this point P over here. So if I can work out what point P is, then I should be able to work out the midpoint and therefore work out the x-coordinate of the turning point. Okay, so we don't know the equation of the graph, but we do know that it has a y-intercept of -10. So we do know that this value of c over here has to be -10. So I'm going to start by writing down the equation, or part of the equation that we know. We know it's going to be y is equal to x squared plus bx, we don't know what that value is yet, take away 10, because we know that plus c is going to be take away 10. Okay, now we know this information here because we know that it does intersect at 5, 0. So I know that when x is equal to 5, y is going to be equal to 0. So I'm going to write that down. When x equals 5, y is equal to 0. Now that's useful because if I substitute that into here now, that should help me work out what b is. So if I substitute y is equal to 0 over here, so that's going to tell me that 0 is equal to, and x is 5, so that's going to be 5 squared, which is 25, plus b times x, or b times 5, which is 5b, take away 10. So that tells me that 0 is equal to 25 take away 10, which is 15, plus 5b. And from that we can work out that b is equal to -3. Okay, so I now know that b is equal to -3, so I'm going to rewrite this equation as y is equal to x squared take away 3x take away 10 is, yeah, okay. Now in order for me to work out what this value of p is, well, I know at this value of p the y coordinate is going to be equal to 0, so I'm going to try and solve the equation x squared take away 3x take away 10 is equal to 0, and I should be able to factorize this. I get x take away 5 times x plus 2 is equal to 0. Okay, so that tells me that either x is equal to 5, which we already know. I'll write that down over here. So x is equal to 5, or x is equal to -2. So the 5 we know, and the p, well, we now know that this p needs to have a value of -2. So in order to find the turning point, I need to find the midpoint of -2 and 5. So to find the midpoint, I'll have to jot it down over here. So to find the midpoint, I need to do -2 plus 5 divided by 2. So -2 plus 5 is 3, divided by 2 gives me 1.5. So my midpoint over here must be at 1.5. Okay, so the x coordinate of my turning point over here, well, it must have an x coordinate of 1.5. Question 24. A ball is thrown from a point 6 meters above the ground. The graph shows the height of the ball above the ground in meters. We need to estimate the speed of the ball in meters per second after 1 second, and we have to show our working out. Now, in order to estimate the speed of the ball, because I've got distance against time, the speed is going to be the rate of change of distance against time. So that's actually going to be the gradient at this particular point at 1 second. So in order to work out the gradient at this point, because it's a curve, I need to draw myself a tangent at this point. So I'm looking for a line that just touches this point over here. So I'm going to have a go at drawing that line. Okay, so we want it to just touch that point there at 1 second. Okay, and I think that's the best I'm going to get. Okay, so that looks like it's a tangent at that point. So I'm now going to see if I can calculate. So I'm going to do my change in y divided by my change in x. So let's start by writing that down. So we want change in y divided by change in x. And that's going to be equal to, well, the change in y, that's at 9.4. And we're going to take away, and that looks like it's 6.6. So we're going to do 9.4 take away 6.6. And I'm going to divide that by the change in x. Well, it's gone from 0 to 2 seconds, so the change in x is going to be 2. Right, so 9.4 take away 6.6 is 2.8. We need to divide that by 2 and we get 1.4. So that's going to be equal to 1.4. So I'm going to have 1.4 meters per second.